Cross multiply, you are correct. So remember when you cross multiply, that's when we do our 4 times 45 equals 9 times x. You guys can use a calculator for that, but since I don't have one, I'm going to leave it in terms of its factors. And then I'm going to solve from here. So how do I get x by itself? Divide by 9. And then I'm going to see if 9 goes into either of these factors. Does 9 go into 4 or does 9 go into 45? Goes into 45. How many times does 9 go into 45?
We just cross multiply.
Yep. Yep, it goes into 5. 9 goes into 9 one time. So we multiply the things in the numerator. 4 times 5 is 20. It's over 1, but we know anything divided by 1 is itself. So x equals 20. Our next one up, we're still doing that same cross multiplying. You end up with 7n equals 49 times 12. We're going to get rid of the 7 because we want to get n by itself. Divide both sides by 7. Again, you could have multiplied out 49 times 12. But I don't have a calculator with me, so an easier way of doing it is leaving it in terms of its factors and seeing if 7 goes into either of them. Does 7 go into 12 or 49? How many times does 7 go into 49?
7.
How many times does 7 go into 7? 1. So we have 7 times 12 over 1. What is 7 times 12? 84. Nice job. Your objective today is to be able to perform dilations, and our first definition was a dilation. This is another transformation with a scale factor k and center c that maps each point of the original image. Let's try this again. Maps each point to an image so that the original p is between c and k. And then we have a reduction. Your original image is smaller. Let's try it again. Reduction, the image is smaller than the original figure, and you have an enlargement. The image is larger than the original figure. So they go hand in hand with what we know. Does anybody need another second on this one? Anybody still writing?
I'm writing up.
Okay. So remember, when we talk about an image, the image has the primes. The one without the primes are the original figure. So here you see that P, Q, R is the original. And then we have the ones with the primes. P prime, Q prime, R prime is the image. Is your image a reduction or an enlargement? Is it bigger or smaller than the original? So if our original is this one right here, what's this one going to be? It's going to be bigger, so it's going to have to be that enlargement. So the first one's an enlargement. And then the second one, you see that you have the letters without the tick marks, without the primes on the outside, so X, Y, Z. And then you see you have X prime, Y prime, Z prime. Is that image going to be bigger or smaller than the original? It's smaller, right, because it's on the inside. So we call this one what? A reduction. We're going to talk about scale factor here. So the ratio between CP prime, the center to P prime, to CP is what we're going to use to find that scale factor. So the image goes on top, the original goes on bottom. So if you're looking for the distance from CP, or C to P prime, what is that distance? 2. That goes in our numerator. And our denominator is the original C to P. What's that distance?
3.
So we see our scale factor here is 2/3. Our next one up, you see again that image stays in the numerator, so the top of our fraction. So the distance from C to P prime is what?
3.
6 in this case. And then C to P is going to be 3. So you just flipped them, hon. So what is 6 divided by 3? 2. So we see that it's double. So if you double 3, the whole side of our image is going to be 6. So we see our scale factor that is 2. So our first one, your original, is that CP because it doesn't have the prime. And then our C prime is going to be the C to P prime is our image. Is that going to be a reduction or an enlargement?
Reduction.
So our original is the smaller one, and it's what going to get to this one?
Yeah. It's enlargement.
It's going to be an enlargement, right? So you know it's going to be an enlargement.
That's what I put the first one.
Okay, after that we have the image over the original. So I am over original. So what is my image here? What's the length of my whole image? C to P prime. 10. Over my original. What's my original? 5. So 10 divided by 5 is 2. So Your scale factor here, once again, is 2. After that one, we're going to look at this one over here. You see your original is CP. Your image is CP prime. Is this an enlargement or a reduction?
Reduction.
It's a reduction because it's getting smaller. So we have a reduction, and then you have image over original. So my image is 8. My original is how much?
24.
24. Do we have anything in common between 8 and 24? 8 goes into 8 one time. 8 goes into 24. So it's 1/3. So notice how it's an enlargement is this whole number. It's bigger than 1. For it being a reduction, you notice that it is smaller than 1. Yes, ma'am. Yes. So the question here says if you have a triangle, P prime, Q prime, R prime is the image of the original PQR triangle. After reduction, find the value of X. So we see here that we have X as a length on the side of QR. So if we want to find it, this first step says write it as a proportion. They want it as a proportion to the side that has X. So it's going to be written as a proportion of QR. Is QR the original or is it the image? It's the original because there's no primes. So that means that goes in the denominator. So we have here QR goes in our denominator. And we have to relate it to the image. So if you look on the picture, which one is going to be the image of QR? Yep, Q prime, R prime. So we are just relating the two, our original and our image, in reference to which one has the X. Now we're going to substitute in the length. So what is the length of CP prime? It's 8. Nice job. And then we have CP, which is 14. Thank you. And then we have QR prime, which has what distance? 6 over QR, which is? Just X, yep. So now we've set up the proportion and we've substituted in for our proportion. After this, it says we need to cross product property, which means just cross multiply. So we end up with 8x equals 6 times 14. The next step is just you multiplying that out. What is 6 times 14? 112? That does not seem... Yeah, I think it's going to be 84. Okay, and then we're going to divide by 8. So if we divide each side by 8, what value do you get for x? 10.5. 10.5. And this one, I'm going to let you leave it as 10.5. If I wanted it as a fraction, remember we could rewrite that as 10.5. And then remember you multiply these two numbers, the denominator and our whole number. So that would give me 20, and then you add 1. So 21 over 2 if I wanted it as a fraction. But 10.5 is fine. Okay, so now after you have the fraction that has your variable, we have to relate it to the one that has both pieces. So the only one that has both pieces is this part right here. So which part of this is the image? The 20, yep, because that's what the part that has the prime. So 20 goes on top. On bottom goes which one? 8. Nice job. Okay, we're going to cross multiply here. So you end up with 8m equals 20 times 2.
40.
Yep, it's 40. We want to get m by itself. Divide by 8. M equals 5. So our missing side length here is 5. So now you guys are going to try to replicate this one on the second half. So again, we start here with the image over the original. You see that the prime is on the one on the inside. So that means the one on the inside is that it could be our image or our original?
Image.
Image. So we want to relate the side that has the variable first. So which one has the variable? Or what is our variable?
N.
It's n. So n's going to go in my numerator because it's on the image portion. And what's the side that corresponds to that n? 4. Yep. After that, we have to use the two that have the same side. So we only have one other one that has the same information. There's no information here. So both of these are known sides. So we have to use it. We end up with, which one's going to be my image, the 3 or the 6? So the image, remember, is the one with the little prime. So which one on here is going to be the side length that goes with the prime? So it's going to be the 3, right? So 3 goes in the numerator. The one without the prime is the outer shape. The one that goes with that is going to be that 6. Okay, now we're going to cross multiply. So we end up with 6 times n, 6n, equals 4 times 3, 12. We want to get n by itself. We divide by 6. N equals 2. So if you look at the two we had here, you saw your image. And this one, was this a reduction or an enlargement on this one? So original to here is our image. It's an enlargement. You see that it's going to be a number bigger for your m. Your m is going to be bigger than your original one here. Over here, you see that your side length n is on the image, and now this one's on the inside. What's this one going to be? A reduction. The side length for n is going to be smaller than your 4, and we see that's true with the 2. So the difference between these two type problems and the one before this is you're solving for a specific side length. Before this, we were looking at the scale factor, which is just one fraction. So it would have been the equivalent of 20 over 8 reduced, or it would be the equivalent of 3 over 6 reduced, 1/2 in the other one. So we're looking for side lengths in these last two. The other ones, we're looking for scale factor.